September 25th, creating double number line diagrams. And your learning target for today, I can create a double number line diagram and correctly place and label tick marks to represent equivalent ratios. And I can explain what the word per means. Okay, so for our warm up today, we've got a number line and we've got some numbers, some decimals, and some fractions that we want to place on this number line. Okay? Then, based on where you place the numbers, locate and label 4 more fractions or decimals on the number line. I'm going to stop. I want you to pause the video and take 1 or 2 minutes to try to do this. Okay? Notice you've got 0 here and 2 down here. Okay? All right. Okay, so coming back together, what should go right in the middle here? If this is 0, this is 2, the middle should go 1, okay? That's how you need to start. You need to start placing things relative to other things, okay? So even though you weren't asked for 1, you need to know where 1 is so you could put a half, where you could put 1.5. I'm sorry, let me back up. A half, and then half of a half is a fourth, okay? Then halfway between 1 and 2 is going to be 1.5, or 1 and 2/4, 1 and 1/2, and then halfway between 1 1/2 and 2 is going to be 1.75, which is also equivalent to 1 3/4, okay? So you really kind of have to place things relative to other things, even though, like I said, you weren't asked for the number 1. All right, so let's get on with the number line, the double number line. The other day we made green water by mixing 5 milliliters of blue water, okay, and 15 milliliters of yellow water. We want to make a very small batch of the same shade of green water. We need to know how much yellow water to mix with only 1 milliliter of blue water, okay? So, on the number line for blue water, label the 4 tick marks as shown. Well, if you've got 4 tick marks between 0 and 5, what are you increasing by? What are you increasing by? Let me point it out to you a little bit. 1, 2, 3, 4, 5. If I've got 5 tick marks and I'm getting up to 5, won't each one of these be 1? Yeah. I've got the same thing here. 1, 2, 3, 4, 5. So what's 15 divided by 5? 3. 3, 6, 9, 12, and of course 15. All right. So, how much yellow water? I'm sorry, I'm getting ahead of myself. On the number line, label the blue. Okay. On the number line for yellow, draw and label tick marks. We did that. Okay. How much yellow water should be used for 1 milliliter of blue water? Right there. 3. 3 milliliters of yellow. How much yellow water should be used for 11 milliliters of blue? Well, I know this is going to be 11. How much are these increasing by? They're increasing by 3. So this is going to be 33 milliliters. And again, if I'm going too fast, please stop the video or rewind it and watch again. How much yellow water should be used for 8 milliliters of blue water? Well, let's go in here and figure this out. 6, 7, 8, 9, then 18, 21, 24, and 27. How much yellow water should be used for 8 milliliters of blue water? And that is 24 milliliters. All right. Why is it useful to know how much yellow water should be used with 1 milliliter of blue water? You can multiply to figure out any amount of yellow water needed for a given amount of blue water. So if you know that constant, this time we increased by 1, this time we increased by 3. And think of it as kind of skip counting. That's what I do. I think of it as skip counting. Okay? So, any questions about that? All right. I want you now, we're going to revisit the kitty cats, okay? Each of these cats have 2 ears, 4 paws, and 1 tail. All right? So I want you to draw a double number line diagram that represents a ratio in the situation. Write a sentence that describes this situation and use the word per. Okay? Do this on the link on today's Canvas page. And again, please continue working on R1 and R5 in IXL. Thanks.